It is the rate of change in in y with respect to x. Now we shall study third part, that is instantaneous rate of change in a quantity with respect to other quantity. Instantaneous means happening immediately or at random, and instantaneous rate of change in one quantity with respect to other means what is the change in a quantity when there is a small change in other quantity. And in this way, instantaneous rate of change in y with respect to x means what is the change in y when there is very small change in x. We have already got rate of change in y with respect to x, and that is delta y by delta x equal to f of x plus del x minus f of x upon del x. It is the rate of change in y with respect to x. And to convert this into instantaneous rate of change, the change in x must be so small that it is approximate 0 but not equal to 0, and change in x is del x, therefore del x is approximate 0, and in term of limit, when we keep the value of del x very near to 0, we write del x tends to 0. So when we take limit del x tends to 0 on both sides, we get limit del x tends to 0 it is the instantaneous rate of change in x with respect to in y with respect to x, because I have already told you that instantaneous rate of change in y with respect to x is also known as derivative of y with respect to x, and it is written as derivative of y with respect to x is equal to limit del x tends to 0 f x plus del x minus f of x upon del x. This is the derivative of y with respect to x. Now we take an overview to all the three parts and try to understand the derivative of a function. Let y is a function in term of x, that is y equal to f of x. Let x is changed as x plus del x, and corresponding change in y is y plus del y. Now we have new function in the form y plus del y equal to fx plus del x. Suppose if as equation second and this is as equation first. When we subtract first from second, we get change in y. This is the new value of y and this is the value of original function. When we subtract first from second, we get y plus del y minus y equal to f of x plus del x minus f of x, or del y equal to f x plus del x minus f of x. This is the change in y with respect to x. Change in y with respect to x. When we divide change in y, that is del y, by change in x, that is del x, then we get del y by del x equal to f of x plus del x minus f of x upon del x. This is the rate of change in y with respect to x. Rate of change in y with respect to x. To change this rate of change in y with respect to x, to convert this rate of change in instantaneous rate of change, we take limit del x tends to 0. Limit to convert this rate of change into instantaneous rate of change, we need to convert the change in x, that is del x, approximate 0, and for this we take limit del x tends to 0 on both sides. This is the instantaneous rate of change. Instantaneous rate of change in y with respect to x. It is also known as derivative of y with respect to x. So we can write it derivative of y with respect to x, and it is equal to limit del x tends to 0 f x plus del x minus f of x upon del x. It is the derivative of y with respect to x. It is also known as derivative of the function from first principle. But you have to study derivative at a point. As you know, derivative is the rate of change, and rate of change cannot be found at a single point. Therefore, we require second point, and for this we suppose the second point very close to the given point, such that the difference between both points is approx 0 but not equal to 0. Now derivative of a function at a point A. Let y equal to f of x is a function. So to find the derivative of y with respect to x at a point A, it is denoted as derivative of y with respect to x at a point A, and it is equal to limit del x tends to 0 f a plus del x minus f a upon del x. It is derivative of y with respect to x at a point A. It can also be written as f dash a equal to limit del x tends to 0 f a plus del x minus f a upon del x. This was the topic derivative. It has been finished. Now we shall study derivative as the slope of the tangent in part 3. Thank you so much.